Hello, everybody, and welcome to the presentation of the paper People Are Not Coins, Morally Distinct Types of Predictions Necessitate Different Fairness Constraints. My name is Eleonora Viganó, and I'm a postdoctoral researcher at the Institute of Biomedical Ethics and History of Medicine at the University of Zurich, Switzerland. The authors of the paper are, beyond me, Corinna Hertweck, who is PhD student in algorithmic fairness at the University of Zurich and at the Zurich University of Applied Sciences, Christoph Heitz, who is professor at the Zurich University of Applied Sciences, and Michele, who is a Marie Curie Fellow at the Politecnico di Milano. Here you can see the overview of my presentation. So in the past years, the algorithm fairness literature has proposed a variety of fairness criteria. And while fulfilling these criteria is typically intuitively appealing, the literature has also shown that many of these criteria are not jointly satisfiable. And this gives rise to the questions such as which criteria should be evaluated and whether fulfilling any of these criteria is a necessary condition for fairness. Brian Haddon's recent paper on statistical criteria of algorithmic fairness provides good reasons to question whether some of the most widely considered statistical fairness criteria are necessary conditions for the fairness of probability estimates. And in this paper, we show that even if the fairness criteria that Haddon's analyzes are not necessary conditions for fairness of all automated decision-making systems, they are still relevant and might even be necessary for most of today's decision-making systems. In fact, Haddon's argument is applicable to only one of two types of predictions, and this type is not widespread in computer science. And the distinction we make between the two types of predictions is based on the moral principle of treating people as individuals. So we conclude that Haddon's argument does not undermine the fairness criteria status of necessary conditions for most of today's decision-making systems. So typically decisions made under uncertainty are based on the assessment of the probabilities of the possible outcomes. And there are two ways of computing probabilities about people, which depend on the data that we use. We have an age group probability when we use data of other people beyond the person whom the prediction is about, while an age individual probability is determined with that of the person whom the prediction is about. These two types of age probabilities correspond to two types of probability-based decision-making practices. An age group practice is one in which we take a decision about a person by employing the age group probabilities attributed to that person. And an age individual practice is one in which we make a decision about a person by employing the age individual probabilities attributed to that person. Haddon does not indicate what kind of probability estimates and thus practice he considers. Now I will present Haddon's argument. So Haddon constructs a case of a perfectly fair and unbiased algorithm in which people are assigned coins which can either land heads up or tails up. And each coin has a label which shows its probability of landing heads up. And the predictor assigns risk scores to people which indicate the risk that the coin they have lands heads up. And the predictor assesses the risk score by simply echoing the label of the person's coin. And as you can see, this is an intuitively and perfectly fair approach. But the problem is that, as Haddon shows, most of the fairness criteria he analyzes 10 out of 11 are violated in this perfectly fair and unbiased algorithm. And the only fairness criterion that is fulfilled is calibration. So Haddon's conclusion is that the most fairness criteria are not necessary conditions for the fairness of predictions. Now, let's have a look at the argument we presented in our paper. So Haddon's perfectly fair and unbiased algorithm is an H individual practice. Thus, his argument proves that most fairness criteria are not necessary for H individual practices. Such practices are so not widespread in computer sciences. H group practices and task probabilities are more common than H individual practices and H individual probabilities, because the data collection of many individuals is usually cheaper, faster, and more easily generalizable than observing one individual over a period. And in addition, in some cases, repetitions of events for the same individual are not possible. Therefore, Haddon does not prove that most fairness criteria are unnecessary for H group practices. The fairness criteria status of necessary conditions for the fairness of H group practices is not vulnerable to Haddon's argument. H group and H individual practices differ from each other from the moral perspective. Let us consider a case of a car insurance company that provides customers with personalized prices based on their attributes. For example, their driving behavior. And that can use two different algorithms for assigning the personalized insurance premium to the person A. We have model 1 and model 2. Model 1 represents an H individual practice, as it has only been trained on A's past driving behavior. For example, the involvement in accidents that were A's fault. Model 2 represents an H group practice, as it has been trained on the data of many individuals. Some are similar to A under some characteristics, for example, gender, in case there is a statistically sound association between accidents and the combination of these characteristics. It seems that model 2 is morally problematic because it uses information from other individuals to make a decision about A. A is not responsible for the characteristics on the basis of which A is judged. For example, it's not A's fault if people of A's age drive dangerously. By contrast, model 1, which uses the H individual practice, uses all information regarding A. This prima facie moral distinction between H group and H individual practices is based on the intuition that predicting a person's behavior based on data of other persons is wrong. And this intuition was found in Beans and colleagues' qualitative study on people's perceptions of algorithmic decision-making in the paper It's Reducing a Human Being to a Percentage Perceptions of Justice in Algorithmic Decisions. In this study, some subjects objected about making predictions about an individual using all information about other individuals. And the intuition that predicting a person's behavior based on data of other persons, that the intuition that this prediction is wrong, distinguishes the two H practices and is based on a moral principle, which we called principle M. This principle requires treating people as individuals, and it is a prima facie moral principle. And this means that there can be other moral obligations that override it in some circumstances. And also this means that people can disregard principle M in some other circumstances. For example, when I have a quick interaction with a stranger, or when I don't have enough information about an individual. In moral philosophy, this principle has been investigated in the context of statistical discrimination, racial profiling, and stereotyping. And in the legal field, Principle M is discussed with regards to the value of statistical evidence for legal proof in courtrooms. So as age group practices violate this principle of treating people as individuals, age group practices are pro tanto morally wrong. I will now address the main objections to the moral distinction between age practices we identified. So first objection, treating people on the basis of individualized evidence requires assuming some generalizations that ground the individualized treatment on statistical evidence. We reply that Principle M does not prohibit to engage in any kind of statistical evidence. There are two forms of statistical knowledge. The first is the inductive generalization on an individual that is formed by observing the behavior of similar individuals. And this form of statistical knowledge conflicts with Principle M. But then there is a second form of statistical knowledge, which is the inductive generalization on an individual that is formed by observing the behavior of that individual throughout time. And this second form does not conflict with Principle M. The second objection is this one. So the fact that scholars do not agree on the validity and bindingness of Principle M indicate that our moral distinction between age practices is weak, as based on a principle that is controversial. Our answer is that we did not argue for an ultimate moral difference. We rather point to a prima facie difference, which has been found in people's perceptions about the morality of algorithmic decision-making. The third objection is the following. So as we know already that age group practices are prima facie morally wrong, qua age group practices violating Principle M, then we should not use such practices nor investigate the necessary conditions for their fairness. This objection commits the additive fallacy, namely, it assumes that in most or all cases, if a fairness criterion has moral relevance, then it must always make a difference. But let us consider the case of an age group practice whose use is all things considered right because it avoids a serious wrong to be committed. So in this case, a fairness criterion can make a moral difference because it can be the moral constraint that makes the use of the age group practice right. For example, the fairness criterion makes the misclassification harm imposed on individuals of different groups proportionate, in the sense that misclassification harms are distributed proportionally among groups. So to summarize my presentation, first, in our paper, we showed that Hedden demonstrated that fairness criteria are not necessary conditions for the fairness of only age individual practices. Second, age group practices, which are the most common in computer science, are not vulnerable to Hedden's argument. Hence, the fairness criteria status of necessary conditions for the fairness of age group practices is not put into question by Hedden's argument. Third, age group practices are pro tanto morally wrong as they violate Principle M. When they are all things considered right, fairness criteria can be considered necessary conditions for the fairness of such practices in terms of constraints to the misclassification harm of these practices. That's the end of my presentation. Thank you very much for watching it. And if you have any questions or comment, feel free to contact me in the Q&A session.